All right, we should be live. I know it usually takes a few seconds, so I like to give it like 30 seconds to really get going here. And I'm just going to make sure the other streams are up in my other tabs. And if anyone's already watching, it's always great to hear verification that you can hear us. It seems like you should be able to, but it's always nice to know in the chat.
I hope so. Otherwise, this will be a fun little exercise for no reason.
Maybe if you're really good at lip reading, you can understand. Also, let us know in the chat where you're watching from. It's fun to hear about, where people are watching, maybe your background. If you're interested in synthetic data, today's topic, maybe a little bit why, or if you've heard about it already, let us know in the chat.
Mm-hmm.
But with that, I'll kick off a little intro. So my name is Sage Elliott. I'm the host for today's Robust and Responsible AI event. We're a community of AI and machine learning practitioners, researchers, designers, and much more, kind of everyone in the field or every type of role in the field. You can think of today's event kind of as a live podcast. I'll be interviewing guests and starting with a specific topic, and then we should have some time for questions at the end, but feel free to put them in the chat as we go. And I always encourage everyone to talk in the chat anyway, even if we don't see it. It's way more fun, especially if you're doing live events, kind of seeing like what everyone else is thinking about the topic. And if you ever want to come on for an event like this, let me know in the Slack, which there's a link in the description, or you can connect with me on LinkedIn and message me there. And today we have our guest Michael with us to talk about synthetic data. Welcome back, Michael. I'm excited to have you back, and you're our first repeat guest, so this is very exciting. And for those who didn't see our last stream together, could you introduce yourself and tell us a little bit about your background?
Hello, everyone. So I'm Michael Galarnyk, as Sage introduced me. As far as my background, I'll keep it relatively short, but essentially I'm one of those people that didn't go straight from a data science undergrad to working in data. I did an undergrad in nanoengineering from UC San Diego. I found that I liked playing with data during my undergrad research on mixing a fluid, essentially using bubbles, and then did a master's in data science and did a lot of research on long-term trends in sleep, heart rate, activity at Scripps Research. So I still wear my Fitbit watch and I still look at my data, which is kind of cool. And during all this, I did a lot of data science teaching. I did an excessive amount of blogging. I made a couple of LinkedIn learning courses. And eventually, because of that, I landed up as a data evangelist at companies like Anyscale. If you don't know about them, OpenAI uses them or uses their open source rate project for distributed computing. I worked at Intel, Converge specifically, on the MLOps side. And then now I work at Parallel Domain, who accelerate perception with synthetic data. So I've done a lot of different things, and they're kind of all interrelated in some way.
That's awesome. It's always fun looking back in your career and seeing how everything kind of relates, even if it's like a little bit of a jump into a slightly different industry, but they all tie together somehow. It's really fun.
I think experiences are definitely very synergistic in most fields these days.
And when you said you look at your Fitbit data, do you export that data and actually run like analysis on it? Or are you
Yeah,
just looking at it in the app?
yeah, it's really cool. So I look at it I pay for the Apple service. So I actually do look at my data. I think it's Apple. I forget who I pay through. It's Fitbit, but Apple charges me for some reason. Anyway, so I look at my data and I see like how my activity and heart rate are inverse related often. So like if you exercise a lot, your resting heart rate tends to go down. I look at it like long-term trends. So like during the holidays, my resting heart rate spiked, my activity dipped, and it keeps me kind of on track. And then additionally, like if people ever had like a surgery or something, or like a severe cold or something, you can often see that in the data, and that's really useful for me at least.
I know for me too, and it is a little off track. We'll get into synthetic data in a second, but it's fun, interesting too. Like I've noticed if I, stop eating at a certain time, I'll have a lower resting heart rate during sleep, or I'll sleep better and stuff. Anyway, it's fun to track your personal data and see what your body's doing.
Yeah, data can really guide a lot of decisions and make your life a bit safer if you use it properly.
Awesome. All right, so let's get into
Sure.
today's topic. Right off the bat, we'll just ask or start with what is synthetic data? It's probably a term people have seen thrown around. I know I see it a lot. I see it come up a lot in posts and really rising a lot more in the last like 2 years or something like that. At
Hmm.
least for my feeds and stuff. So, what is synthetic data?
So there are a lot of different potential definitions of synthetic data. So I'll give you mine. So synthetic data is data that's generated by a computer program or an algorithm rather than being collected from a real world source. So synthetic data often simulates real world processes. So this could be for autonomous vehicles from the behavior of other road users all the way down to the behavior of light as it interacts with surfaces. Um, Synthetic data is often used in machine learning and, quite frankly, other fields to train algorithms and models, since it gives people the ability to generate as much perfectly labeled data as they like. And I really want to emphasize labeled, because in real world data, we've all had it where we're sitting there just like clicking and labeling data, and it's very painful. And you have really high um, price professionals often labeling data, looking at what's wrong with their labels, and it's definitely a painful endeavor. So, oh, I should also mention in parallel domains case, we focus on synthetic sensor data that could be used to better train as well as test perception models. So this can include anything like realistic cameras, LiDAR, and radar data. So
That's really neat. I think I saw, and I'm sure we'll get into this
yeah.
a little bit later, but I saw a demo or a video showing capturing data from a synthetic camera perspective. So you have like this
Hmm.
imagery, but it was also simulating the lidar data. So you actually had like the depth perception too, which I thought
Hmm.
was really cool, combining all those sensors into one synthetic piece. That's something I hadn't seen before.
Hmm. It's definitely a lot of work. So the people that are uh, grinding every day to make the synthetic data that much better, it really makes an impact on real world events and real world processes as well. So,
Yeah, and you had mentioned, having label data. I don't know if anyone watching right now put in the chat if you've done data annotation, especially if you've done things like object annotation with bounding boxes or
mhm.
segmentation where you're tracing around objects, and it can take a long time. So yeah, it can save so much time. Can you give us another example of synthetic data? Maybe go in and describe like a use case of it could be self-driving cars, it could be anything else that comes to mind.
Mhm. So first of all, with the self-driving cars, that could also be attached to, like, you have something similar for drones. You can have mobile computer vision. You can have a lot of different things in that sort of area. So just keep that in mind. But I've also seen companies create synthetic images to improve things like plant classifiers to handle adverse weather conditions. So Gretel, for example, basically create a model to do synthetic snow, because oftentimes when you're gathering data, the weather is way different. And we see this for autonomous vehicles as well. If you're just gathering data in sunny San Diego, where I'm from, where it never rains and the weather's perfect, and you have very set road signs, um, things can be very different when weather changes, because no one or not a lot of people around the world live in a place that has perfect weather year round, for example. So people often simulate weather and a bunch of other stuff. Another interesting example is generating deepfakes that could actually be used to test face recognition systems. This is kind of getting into a little bit about privacy, because you really don't want to have a database of people's faces stored for a lot of places as well. And we can talk about synthetic data for privacy as well, because oftentimes people use synthetic data as well for things that have massive privacy restrictions and as well as safety restrictions.
Awesome. Yeah, I think we'll dive a little bit into those applications next.
Hmm.
But I wanted to describe maybe what the example would look like. Like, what does the actual piece of synthetic data look like for someone? Is that like a 3D? I know it varies on
Hmm.
application, and just like you said, you have all these different types of sensors that you can create
Hmm.
data for. But at maybe just at a high level, like one kind of maybe simple example, what does like a piece of synthetic data look like? Is that like a 3D generated asset? Is it a photoshopped cut out piece of data from another photo on a different photo? What does that look like for one example?
So it really depends on your use case and what you're trying to do. So for us, it typically is beautiful images, as well as annotations. I think that's one thing we talk about, things looking one way, especially for like images, but it's really the annotations. It's looking at optical flow, looking at a lot of things that go along with said images. It's not just having a beautiful thing that comes out of a process where you go from a rendering engine to sensor simulation to ground truth generation. It's not just the image, it really is the thing that goes along with the image, if that makes sense.
Yeah,
And that
totally makes
can
sense.
look like a really souped up, amazing Grand Theft Auto, essentially, at least in our case.
Right. So yeah, like you would have an example of a car, let's say, and it could be a 3D asset, but then there's all the annotations that go along with that. So in a 3D space, you have different types of annotations, like the 3D bounding boxes around a car, let's say, that gets created with it, and then you're
Mhm.
more easily able to feed that data into some sort of machine learning algorithm, let's say in this case, and then it can learn from those labels.
Yeah. And there's so many different applications of synthetic data. I don't want to just talk about just images. People do things, they create tabular synthetic data, they have time series data. There's so many different things you can do. It's just I happen to focus on synthetic image generation typically.
Awesome. Makes sense.
Yeah.
All right. So let's dive into where we were kind of going before.
Mhm.
Maybe what are some of the top reasons why people may want to consider using synthetic data in their applications, or let's say to build a machine learning model, or any other use cases you want to bring up?
So there are really a lot of reasons why people may want to use synthetic data, but here are some that I think are important from my background. So as we mentioned earlier, real data collection and especially labeling isn't really a scalable process. We talked about like manually like clicking and labeling. It's painful. Additionally, sometimes that really can cause other problems too, as I'll mention in a bit. Um, but you can also have cases where manually labeling real data is actually really difficult, if not impossible. So in the perception domain, accurate estimation of things like depth or optical flow, so how fast things are moving relative to each other, is my horrible definition of optical flow. And doing that from single images is really, really hard, if not impossible. Um, I think people often want to use synthetic data for things like privacy and safety concerns. So people often think of synthetic data for healthcare, but also can be used for like robotic applications, as I mentioned with the autonomous vehicles. Better training can lead to better outcomes, and that's a really PC way of saying you really want to train a model before it goes out in the wild in as a real setting as possible, so it makes less errors, it has less crashes. You may not want to you want to have edge cases covered in your model training, but you don't necessarily want to have endangered pedestrians and have a model train on real life in a million different facets that way. Um, and especially for healthcare, I mean, privacy is really important. You don't want people having your healthcare data out there and so on and so forth. I think one big thing that people encounter, and the reason why people do anything in the world, is cost. So collection and labeling is, when I mentioned it's not scalable, sometimes for people that really means that you don't want to drive around in the autonomous vehicle domain and get an unlimited amount of hours because it's time intensive. You can't drive to uh, certain types of maps, I guess, because a lot of times things are trained in big cities and your offices are located and so on and so forth. I'd also argue for a lot of people, their real data is great and it has a place, and people pre-train synthetic data and they fine tune real data depending on how they do it. But their real data may not be programmable. So sometimes you really want some diverse experiences. You might have class imbalance. I talked about San Diego earlier, where San Diego has beautiful weather, but not everywhere does. So you want to like diversify your weather, diversify road textures, and you might also just want a large volume of data. You can't necessarily get those edge cases in large amounts of data. You can't just follow ambulances around all day and get images of them, essentially. And then I think the one thing that I never thought of that was pointed out to me for a lot of people, and this probably occurs in your life as well, is development velocity. So we talked about sometimes how labeling data can take a long time when you're actually just manually labeling things. But for a lot of people, they use it to kind of increase the speed of getting their product to market. They use it for training, but they might also use it for retraining because models often decay, as you know. There's a lot of MLOps applications where it's about keeping models as current as possible, so your recommendation system keeps on working pretty well. You might also use it for testing. Uh, because you might have, you want to make sure that your model's still working when you retrain it on real data. Basically to keep models performant longer, because a model is only valuable if it can stay current and stay useful, essentially.
Yeah, I love that idea of throwing it into like almost using it to evaluate a model.
Mm-hmm.
Maybe the model's even already in production, and you're creating these use cases that it potentially hasn't seen yet, and then you want to track like, all right, is my model biased or something like that in this new data that maybe it hasn't seen? And I think it's so cool, like you were saying, generating these edge cases that you either can't capture or are really hard. Like you were saying, you don't want to endanger life. Another use case I'll just bring up real quick is like if you're in a manufacturing setting. I have a background doing like manufacturing and reliability engineering in hardware space. And for example, if you're using computer vision to look at like a defective product, well, you don't want to like destroy a whole bunch of products to train your model on, right? So like maybe you have one or two, but if there's a way of synthetically creating that data, and then retraining your model or training your model on that data that does a good enough job where when a real failure happens, you're going to detect it. That's awesome, because yeah, you're not going to spend like thousands of dollars breaking stuff if you don't have to.
Mm-hmm. I mean, I'm sure some degree of breaking things to learn about things breaking, I guess, but you really want to minimize loss of product and loss of resource, and as well as loss of potential human life if you're going for things that can be a little bit more dangerous, things that can explode and stuff. So
Absolutely. And I think the development velocity is really cool too, and something that I think we'll see way more of people starting to use to get their products off the ground, because it's hard to get data. But if you can generate that data, get a model working and put it in production and see how it's performing, that's awesome.
hmm.
All right. So the next question is, what industries have you seen adopt synthetic data, or what industries do you think will be adopting next? And it kind of sounds like it could be all of them, but maybe there's some that kind of have a little bit more of an edge right now when it comes to adoption.
Of course. So, as you know, I'm biased. I work for a company that makes synthetic data for perception. So, I really do think that you'll see a lot more synthetic data for automotive, drone, and like computer vision applications in general. And basically, this is just because, as mentioned earlier, um, the real world is really not enough in terms of safety and accuracy as we'd like. And on a personal level, and based on my previous work on wearable devices, I really can't see how like healthcare is not transformed by synthetic data eventually. So I know it moves slowly as a field, and people have been talking about revolutionizing healthcare for ages, um, because it's taken a little bit of time to get some of the advances in the rest of fields into healthcare. But most types of healthcare data have really expensive labeling. Often you have to have doctors. You don't have a lot of data. It's not like certain fields where we just have essentially unlimited data if we try to generate as much as possible, or if we try to collect data in the real world as much as possible. You probably can generate a lot of data. It's expensive, but for healthcare, you can't exactly get rare disease X and generate data for that. You really don't want to either. So, for example, for like heart arrhythmia detection, it's not only challenging since annotation of signals for heart arrhythmia are very tedious and costly, but you also have privacy restrictions. Some events are really, really rare. So I really see healthcare being transformed with synthetic data eventually, even just for privacy reasons. Yeah.
I think that makes a lot of sense. And I would say those are the two that I also feel like, just from what I know, and I don't work in that domain right now, but those are the kind of the two that I see the most about as well. And just for all the reasons that we highlighted, it's hard to get all these data and variations. And like you said, you don't want to give people diseases or break them. Like we didn't want to do that with product and manufacturing. You definitely don't want to do that with people. um, when should someone start considering using synthetic data? Is that kind of a right away thing? Like you don't have any data right now, you have an idea for a project. Do you and I'm sure it depends on the application, but maybe is it something people should consider right away, like as they're training their first model for a proof of concept?
So a couple things. I'm a big believer in if something's currently working for you and you don't have to change, people often don't change because there's no inertia to change. So if you're happy with whatever you have and it's good enough, and you're not trying to improve model performance, you're not trying to make things a little more cost effective because of your use case, stick with just real data if you like. But when I really see people start using synthetic data, oftentimes it's like you said, it's I want to try something and I just don't have the real world data, and it's so expensive just to gather it to make a quick proof of concept for something that you might want to start with synthetic data. So people just use synthetic data. And then obviously when people scale or they have problems where they don't have diverse enough data, their labeling is not scalable, things are too expensive, it's dangerous, then people turn to solutions like synthetic data to augment their existing data sets. Of course, if you just want to bootstrap something, you of course can just use synthetic data, and that might actually work out fine depending on your application. And we actually have a CVPR ML contest coming up. We're encouraging users to basically use real and synthetic data. And I can share the link with people in the comments below after this talk. So.
Oh yeah, that sounds awesome, and
Yeah.
Definitely send me the link, and I'll put it in the description so anyone watching this after can go find it. It won't be in there right this second if you're watching live. And can you explain what is a CVDR? Is that
Sorry, CVPR? So Computer Vision Conference. My bad.
No
I don't always enunciate things like I should, which is a real problem when you're doing a lot of podcasts. So
I definitely don't either. So anyway, want to explain what that is a little bit more? That sounds awesome.
Yeah, so I'll keep it really short because some of this is still details to be finalized, I should say. But essentially, every year, CVPR has some sort of Woodscape challenge. So Vallejo hosted semantic cementation in 2021 at a conference, and then an object detection task in 2022. And people really like this sort of challenge. So the challenge this year, and I can check to see if it's still current, involves training a single model that performs best on real and synthetic data for the task of moving object detection, which is actually not that easy. And the annotations are pixel level, and it's really just a good opportunity for people to train models that perform well on a couple different classes like pedestrians, riders, vehicles, bicycles, etc. And yeah, I recommend people try it out, see how it goes, and I'm looking forward to seeing the results later on this year.
That sounds awesome.
Yeah.
I might even want to partake in that competition. I love doing some object detection tasks, especially if I don't have to hand label everything myself.
Yeah, that's really painful.
All right. So we've mentioned, I think, parallel domain a few times and stuff. I want to give you the opportunity to tell us a little bit more about what you're currently working on there.
So obviously, as someone in my background, I do a lot of just blogging in general, educating. So some of that is stuff like this, educating people on the importance of synthetic data, why to use it, when to use it, as well as some best practices around synthetic data. So I wrote a blog that's probably the impetus for this podcast originally about the 5 reasons why you might need synthetic data. And that's on K Nuggets now. I'll share a link after the podcast. So I do some stuff like that, as well as writing a blog on like ML best practices for synthetic data with perception tasks, essentially. So synthetic data best practices, basically. And that blog isn't done yet, but I'm happy to share a link to the documentation, which is essentially the same thing. So a lot of educational stuff. And then lately, I've really just been playing around with generating synthetic data and just seeing what it can generate, how it helps edge cases that I'm interested in. And yeah, that's most of what I do. It's a lot of fun, and I really recommend people check out these resources, which I'll share later.
Yeah, and again, anything I have a link I know to parallel domain, and maybe even the blog post in the description. But anything else you want to share, I'll include later, so people watching can go check these out.
Yeah, maybe I'll share our parallel domain Instagram, which I just started. It's a lot of fun.
I actually love computer vision companies are one of the few tech companies I feel like that can have a really good Instagram presence.
Yeah, it's a lot of fun because a lot of these things, they're really useful for helping people. They're useful for training models, saving money, saving lives, but also they can be really aesthetically pleasing to look at some really pretty images and so forth. So
yeah, it's just fun seeing how I don't know, you can segment things in images and stuff too, like, you know, tracking animals or
Hmm.
cars or whatever it is. Just there's something really cool to about looking at these like videos and images.
Yeah, definitely.
Do you want to mention a little bit more about parallel domain and I mean, I think we've talked a little bit about it. I don't know if there was anything else you want to call out.
Not necessarily. I'll just say that we do synthetic data for perception tasks. So if you're in the automotive space, you're in the drone space, or mobile computer vision, feel free to reach out. I'm also just happy to talk about synthetic data in general to anyone who reaches out over LinkedIn, Twitter, whatever.
Awesome. Awesome. And I always like to ask, so we'll wrap up soon. We're almost at our 30
Mhm.
minutes. But I want to ask, what else are you excited about right now in the data and kind of ML AI space?
So one thing that I've been excited about for the last couple of years is how accessible it's becoming. So when you and I started out in the ML space, it used to be a lot of trouble to install things. It used to be a lot of trouble figuring out libraries, figuring out resources to learn libraries. But nowadays, ML is becoming more and more accessible. It's about uh, so much easier to get started now and actually contribute. So those are things I'm generally excited about, just in general for people getting started in ML. I'm also really excited about how much better our tooling has become. So when I did a lot of stuff in distributed computing, I still do some stuff in distributed computing. Um, I really liked how we can scale things now. So as Moore's law kind of has waned a little bit, we're able to distribute compute across multiple nodes. It makes things so much better. Um, and right now, of course, I'm excited about synthetic data because it's really costly, time inefficient, and potentially dangerous to not work with synthetic data in some regards. Yeah.
Awesome. Yeah, I'm very excited about all the accessibility as well. And last time you were on, we were even talking about like no code solutions, and
Mhm.
there's just, you know, so many cool tools coming out where you, even if it's low code, it's just like the libraries out there and stuff make it
Mhm.
way easier to get started. And like you're talking about with synthetic data, you no longer necessarily have to manually label everything. Like
Mhm.
there's just so many cool tools that it's like, oh great, I can actually build like a proof of concept or like whole solutions, you know, in like days now versus like I feel like before it would take, I don't know, months sometimes to get all the
Yeah,
data and get a model out.
the proof of concept stage is definitely a lot more doable now than it was years ago in a lot of regards. Unless you're doing something really crazy, really cutting edge, then obviously it's harder to get started. But for the no code stuff, that really makes the barrier lower, and you can really just get started and get a dirty model out, or I should say, a less good model out quickly sometimes, or even a good model. And then with synthetic data, oftentimes that can alleviate the cost of actually getting data to try something out, see if it works, and then okay, well, this works with synthetic data. Could it also be better if I got real data and then combined it with synthetic data? So,
Yeah, that's awesome. And there's a question
mhm,
that someone asked that, if you don't mind answering,
sure.
they ask if there's a risk for bias in the creation of synthetic data, just as kind of like there's a risk a lot of times if you're, you know, collecting
Mhm.
real world data. Is there risk with the synthetic data? And if so, how can they navigate that?
So that's not exactly always a simple question. I'll get to it in a second. But essentially, if you're creating synthetic data that resembles real world data, then obviously you're sometimes carrying over the bias from the real world. So for things like autonomous vehicles, for example, it could be less of a concern than something, let's say, like healthcare, maybe, because if you're navigating real world physics and your synthetic data has bias from real world physics, then it's probably less of a problem. Of course, there's definitely things you can do, which I'll link to like in the comments below after this, about like synthetic data best practices because you want to avoid bias. It's not exactly, it depends on your use case, really. Um, but yeah, it's definitely a problem, especially for other domains other than like autonomous vehicles. So,
Yeah, and I'd imagine in some cases, like if you have a little bit, I mean, you have control about data annotation stuff too.
Hmm.
Sometimes it depends on how you're getting your data
Hmm.
and collecting it. But yeah, just like if it's mirroring the real world, maybe there's some of that bias in there. But I can imagine if you have control over some of the
Hmm.
generational aspects, you could potentially mitigate a lot of that bias. Or like I think you had mentioned earlier, right? Like if you have a smaller sample size for some population, you'll actually be able to generate more data
Hmm.
and add more to that distribution, and then hopefully create a less biased model. And that's something that you could even do, just like we mentioned before, have a model out, kind of monitor for it, and you can
Hmm.
segment your data and see how it's performing on a specific class or feature, and then kind of maybe generate data according to that and retrain your model.
Yeah, there's so many different solutions to this sort of problem. So one thing people often do is when they generate synthetic data, they have some edge case in their real data they can't necessarily solve. So they'd say they don't have a lot of construction sites in their data for autonomous vehicles. Well, if they generate synthetic data um, that's super biased toward construction sites, that could also be a problem too. So it's not necessarily an easy sort of solution, but I can link to some resources on that.
Yeah, thank you, Cannon, for the question. That
Mhm.
was a great one. And
And
I
feel
know
free to reach
we're
out.
oh yeah, yeah, and all Michael's stuff is in the description. So if you want to connect with them in any of the places, I think those links are already there. All right, so I know we're at our 30 minutes. I'll just ask before we go: is there anything else you want to mention? I know we've covered a lot in synthetic data and all the stuff you've been doing, but if there's anything else you want to shout out, now's the chance.
No, just reach out to me about literally whatever. Follow Parallel Domain on LinkedIn, Twitter, and even Instagram because I promise it'll be a lot of fun. We have some cool videos coming out too.
Awesome. Yeah, I'm excited. I love like I said, I love watching the computer vision stuff. So I'm gonna go follow the Instagram for sure. Someone said, "Great podcast. Thank you so much for the the nice feedback, and thank
Thanks
you,
a lot.
Michael, for being on. I think we'll go ahead and wrap up. I'll let you say goodbye, and then we'll end the stream.
Okay, bye everyone, and thanks for having me again, Sage. It's always a pleasure to chat, and I hope we talk soon.
Absolutely. Thank you everyone for attending and the great question. And we'll go ahead and end the stream now. And sometimes it takes a second, so it's like an awkward